Okay, folks. Let's go. On Wednesday, we started talking about the subatomic particles, along with a couple of other pieces of information associated with the atoms of the element. One of the things we discussed is that when we call an element by its number on the periodic table, that number has a specific name. It's called the atomic number. The atomic number is equal to the number of protons, and in a neutral atom of an element, it's equal to the number of electrons. Because we say atomic number 9, and we look up to the periodic table and find number 9, we also can determine its elemental symbol, which is a capital F, for fluorine. Another term that we talked about is the mass number. The mass number, by definition, is equal to the number of protons plus the number of neutrons. We know the number of protons because we know the identity of the element. The mass number, therefore, we can take the mass number and subtract out the number of protons, and we would have the number of neutrons. The number of protons and the number of electrons are constant in any neutral atom of an element. They're always the same. The thing that can vary is the number of neutrons. And the number of neutrons determines what isotope of the element we're actually working with. And so we have a couple of different symbols that we use for an isotope symbol. You can either use the elemental symbol, raised to a power, or you can use the elemental symbol dash that number. Where in this case, we're representing the, whether it's the superscript to the left or whether it's the X to the from the dash, that is representing our mass number. So what we're going to do today is we're going to look at the more common way you're going to see this type of question. And I can guarantee this is probably going to be about a third of the next exam grade. Okay. Let's say I have erbium 170. I want you to fill in all of the rest of the pieces. The first thing you're going to do is you're going to go find erbium on the periodic table. Erbium is element 68. What does that number tell you? I heard it tells me the number of protons, which is correct. What else does it tell you? The number of electrons, because the protons and electrons have to be the same. What else does it tell you? Atomic number. Okay. I'm very glad you asked that question. I was just asked, is this the mass number in red below it? The answer is no. This is called the average atomic mass, not the mass number. They are different. One has decimal places. The other one is a whole number. The average atomic mass can have decimal places. The mass number is going to be a whole number. But remember I said the different isotope symbols? In this isotope symbol, I'm giving you the mass number. So the mass number in this case is 170. Now to get the last piece, you got to remember this equation. Mass number is number of protons plus the number of electrons. Excuse me. Mass number is the number of protons plus the number of neutrons. So if I have a mass number of 170 and I subtract out the number of protons, I get the number of neutrons. Let's look at yet another example. What if I give you atomic number and mass number? What does the atomic number tell me? What number it is on the periodic table, and I gave you number 80. So I go over here and I find number 80, which is mercury. What else does that atomic number tell me? The protons and the electrons. I need two more pieces of information. One, I've got part of the way there. The other one I'm missing. I need the mass number for the isotope symbol. And then I need the number of neutrons. And neutrons, again, we memorize this equation. Mass number is number of protons plus number of neutrons. So 204 minus the 80 is going to give me my number of neutrons, which is 124. Here's what the first two things illustrate. Well, actually, let me give you this next one, and then we'll talk about what everything illustrates. Okay, what piece of information do I probably want to start with? The electrons, because the electrons, protons, atomic number, all the same digit. So it has 34 protons and it has a mass number, or an atomic number of 34. Atomic number 34, just selenium. Now I just need the mass number. Mass number is number of protons plus number of neutrons, which is 82. Folks, these first three things illustrate the fact that I either will have to give you the mass number or I'll have to give you the number of neutrons to get the mass number. You aren't expected to know the mass number. So you will either be given the mass number or you'll be given the number of neutrons so that you can get to the mass number. Let me give you a moment to work through a couple. Okay, let's see how it's going. Calcium 43, the first thing I look at is what is calcium? It's 20. So what does that 20 tell me? Tells me the protons are 20. It tells me the electrons are 20. And the atomic number is 20. What does the rest of that isotope symbol tell me? The what? That the mass number is 43. So you get 23 neutrons. In the next one, I gave you the atomic number and the mass number. Which one do I want to start with? Atomic number. What is the atomic number? 24. So what does that mean? 24 protons, 24 electrons, and what else? Huh? The what? The element, which is? Cr. What does the 54 tell me? That's the mass number, so I should finish out my symbol. Subtract 54 minus the number of protons, and you'll get the number of neutrons. The next one, we have 82. What is that? That's the number of protons. So what else is it? The electrons and the atomic number. What else does it tell me? Okay, what else does 82 tell me? The element, which is lead. Okay, technically it is the protons plus the neutrons. I mean, yes, you can add the electrons, but technically to get the mass number, it's protons and neutrons. So 82 and 122 is 204. If I give you the symbol just Li, what is it? It's element 3, which is its atomic number. So it's its number of protons and number of electrons. It also has 3 neutrons because 6 minus 3 is 3. The last thing I needed to do on both of these, because I forgot, is put it up there. Now, folks, one of the mistakes I see students make is they get in the habit. First of all, I took this from one of your homeworks. There's about equal number left that we haven't done. But don't get in the habit of it being in these column orders. I can mix up the columns. I could ask atomic number, number of neutrons, number of protons, number of electrons, mass number. It doesn't have to be in this order. So don't get in the habit of going, oh, well, the first, third, and fourth column are all going to be identical. That may or may not be true. You got to know your terminology. Now, yes.
I guess when it comes to lab tests or whatever, when it comes to things involving periodic table, do we need to recognize the name just by abbreviation?
No, I gave you a copy of the periodic table you're going to receive on all exams. And if you look at it, it has the element symbol and the name. Now, just as a reminder of what this means, let's use lithium because I won't get too big, but you better be prepared to draw. It means that there are 3 protons and 3 neutrons in the nucleus of the atom. That is where all of the mass is in the nucleus. Pretty much all the mass is in the nucleus. And then as far as we're concerned, it has 3 electrons somewhere in the cloud. That is what I'm asking you to be able to mentally understand regarding the structure of the atom. This is what an atom looks like. The majority of the mass is found in the nucleus because that's where all the protons and neutrons are. The electrons are in a cloud around the nucleus. Questions? Yes.
Are we going to be able to have to tell, like, what electrons are on the shell?
Okay, the answer to your question is no. That is a task that so the question that was asked is, are you going to have to be able to tell which one are in what shell, what subshell? Don't freak out if you don't know that terminology. That is something that is left for College Chem 1 and General Chemistry for Health Sciences. So all I do is get the basics down, and then I let them expand upon it in that particular subject area.
I guess at like a microscope, is this exactly how you can see, or is we're not able to see that much?
Under a microscope, technically you can't see until you get to gold because the atoms are too small. So how did we determine this? Basically, researchers did some various experiments that allowed us to determine the basic structure. And the basic experiments are described in one of the videos that you're supposed to watch or are to watch.
Going back up to the chart, why are the first 2 the numbers on the front, and on the other 2, is that just the different?
Okay, I'm glad you asked that. Remember, there are 2 different variations I can use. There's actually a third one, but I never use it. But there are 2 variations of isotope symbols I can use, and it doesn't matter which one I use. So whichever one you're more comfortable with can be the one you use. Other questions? So like I said, your upcoming test, I expect a third of it to be a table like this. Every single one of those answers up there is worth a point. So you can expect it to be a significant little table. Yes.
So, I'm sorry, this is going to sound dumb. Do we have to make the table? Is the table on there?
The table's already on there. It's a lot like what I do. It looks like what I did, what I put up there for you to work. So where I give you a couple of pieces of information, you got to fill in the rest. But the table is already there.
Is our second exam just our second exam, or will it be kind of as a midterm?
You don't have a midterm. Your second exam is just the second exam. And I did post what was going to be on that exam on Blackboard. It should be available already for you to see. It's going to have this information plus what we will be going over soon. Up through average atomic mass. Yes. Next Friday. What?
watch the videos. I wasn't aware that we had any.
If you look in every single folder, there's a flipped classroom video. And those are the videos that go over the background information about what we're doing problems on in class. Other questions? Okay. So we have one more thing left that's going to be on the exam. And we're going to be doing that on Monday. And that is we're going to be calculating the average atomic mass. The average atomic mass takes into account all naturally occurring isotopes of an element and their abundance. Earlier, I was asked, is that red number on the periodic table the mass number? And I said, no. It's the average atomic mass. In other words, we are going to learn on Monday exactly how to calculate that red number on the periodic table. Yes?
Is that why it's just a little bit higher than all the masses in the chart?
Okay, I'm glad you asked. The question is that why it was a little bit higher than the masses I gave you in the chart? The answer is, if it was higher than the masses I gave you in the chart, yes, that is the reason. Because I only gave you one isotope of the element. And again, for example, chlorine has two isotopes. It has isotope chlorine 35 and it has isotope chlorine 37. It's the two of them combined that determine that average atomic mass of 35.45. Carbon has three isotopes that are naturally occurring. It has carbon 12, which makes up like 99% of the compound. It has carbon 13, which makes up like 0.01. And it has carbon 14. That makes a very, very, very small amount. Because the majority of the carbon is carbon 12, that's why that number is so close to 12, but not 12. So yes, the average atomic mass takes into account all naturally occurring isotopes, not just one of them.
So does that mean like there's a secondary periodic table? Because when you were talking about like carbon, like we have these different masses, and I know that we're using, well, we're not really, we're using the atomic number to find things, but like if I only see one set of carbon on it, it's only mass that's the other.
Okay. So the question is there other periodic tables? The answer is no. You only see one average atomic mass because it's taken into account all the isotopes. If you want to see all the isotopes of the elements, you actually have, you can go out online and say, give me all the naturally occurring isotopes of carbon, and it'll show you all through. But carbon itself, what you see on the periodic table is, number one, the atomic number. The atomic number for every carbon is identical. It is 6 because it has 6 protons, and the protons is what determines the identity of the element. So it stays constant. The only, the symbol stays constant. And then that 12.0108, that is because it has carbon 12, 13, and 14 as its isotopes. But when we take all those isotopes and average them together, it comes out to be 12.0108. And this is the number we're going to tend to use rather than the individual isotopes. Other questions? Did that answer your question? Yes.
Our question is not related. Is density going to be on the exam?
Okay, I will tell you what's going to be on the exam. I haven't written it. I'll know Monday definitively because I plan to write it on Sunday. Yes, density will be on there. You will have to calculate density and you'll have to use density as a conversion factor. You will have a set of periodic tables. This test will look thick because I only put 2 periodic tables per page. And you'll have to go in and highlight the metals or the non-metals or the metalloids. You'll have to go in and highlight. Well, and what I mean by highlight is just color it in, or it all depends on, make sure you read, because I may ask you to color it in or I may ask you for the symbols. Make sure you read what it asks you for. It may ask you, give me the alkaline metals, give me the alkaline earth metals, give me the halogens, or give me the noble gases. It may ask you to give me the symbol for the element that is in group 12, period 5. It may ask you to give me to highlight the main group elements or highlight the lanthanides. So this goes back to all of that periodic table stuff that I went over and how the periodic table is arranged. You will have a table. And I'm saying you will have a table that requires the following information. What is the charge of a proton? Where is it located? What is its responsibility? Same thing for the electron and the neutron. I'm going to have you draw an atom of a specific isotope. You will have to fill in a table like that one. And the only thing that I haven't discussed as of this point is the average atomic mass, which we will discuss on. I can guarantee that as your test. Now, how many of each problem, I don't know yet, so don't ask that one. I haven't written it, but I can guarantee those concepts will be on the test. Other questions? So we're getting out of our most busy. Have a good weekend. Study. Do the homework, optional homework. It'll help, including if you do the optional homework, it'll also help with highlighting the periodic table and remembering what's what, because there is one of those homeworks as well. Optional, no. Only what's on active gets graded. The optional, though, has looked like tests in the past. as long as you ignore my handwriting, I've already taken care of it, and you can have that one. Oh, you'll get a brand new copy for each test. So on the test, you will have. Oh no, you're going to get a copy of this. Oh, okay. So I can use this now. You can use that for studying purposes. It's just this is what you're going to receive on the test and what you're going to have to work with.